Hello, and thank you for joining us in this session, Better, Faster, and Lower Cost Storage, Optimizing Amazon S3. My name is Matt Sidley, and I'm a Senior Product Manager here on Amazon S3. Today, we see customers of all sizes across every industry vertical migrating every imaginable workload to Amazon S3. These workloads span from data lakes to DNA sequencing, customer call center data, and autonomous vehicle data, just to name a few. And the reason for that is that Amazon S3 provides industry-leading performance, scalability, availability, and durability. At the same time, we provide easy-to-use management features to manage all that data. S3 is the only cloud storage service that lets you manage data at the object, bucket, and account levels, make changes across tens to billions of objects with a few clicks, configure granular access control policies, optimize performance and save costs by storing objects across numerous storage classes, and audit all those activities across your S3 resources. When we think about optimizing storage performance and cost on Amazon S3, we like to think in terms of 4 pillars. The first pillar is defining your application requirements. Understanding what your specific requirements are is key to optimizing both cost and performance. For example, you might have a media asset that is downloaded by many users and has a high availability requirement. Or maybe you have an archive that's a backup copy and it can be offline for a period of time. Your application requirements drive your storage and cost requirements, and you are the best person to understand what these are. The second pillar is data organization. Within an organization, we expect to see a diverse set of data sets spanning different departments and even projects. We have seen that it can be really powerful to organize your data in the beginning if you want to effectively optimize both cost and performance. The third pillar is all about understanding, analyzing, and optimizing your workload based on how that behaves over time. We expect to see a wide diversity of data sets across your organization, accessed at different rates, and requiring different levels of performance. The fourth pillar is what we call continuous right-sizing. And when I say right-sizing, it's really about choosing the right storage class for your data sets that you organized and setting up the right access and policies for your requirements. So let's start by first discussing your application requirements. As we said, the first step to optimize is to really understand your application requirements. And let me illustrate that with a few examples. Perhaps you have a media library, and you have many users that access the video content and you need to immediately stream them to your end users. In this case, you probably have a very high performance and high availability requirement. Or perhaps you have a machine learning use case where you're storing historical data for long periods of time, but you need to keep that data around to do model training at a later point in time. Or alternatively, maybe you're storing backup copies and it's a secondary backup that you want to keep in a single AZ. No one knows your applications as well as you do. So you are the one that defines these requirements. And there's a couple key questions to ask yourself. What durability and redundancy do you want? What availability is right for your use case? How often do you access your storage? What performance do you need? Milliseconds or minutes or even hour retrieval times? And finally, what are the size of your objects and how long do you want to store them in Amazon S3? Once you define your application requirements, next you need to think about how to organize your data. And you want to organize your data in a way that makes sense for the business units, applications, and users accessing these data sets. The first step is creating buckets, which are S3 resources to upload data across different business units within an account. And to further organize your data by projects or teams within a business unit, you can use key name prefixes, which are names in front of your objects to infer a folder structure that helps you further keep things organizationally simple. On top of that, you can also use object tags, which are key value pairs that help you further categorize your objects across internal use cases by associating up to 10 tags per object. Once we organize our data in the right way, we can do things more easily like apply fine-grained access controls and permissions across different departments, teams, or even users. We can apply lifecycle management rules to transition or expire data for specific prefix or object tag-based filters. Or we can use tools and services like CloudWatch Metrics, which allows you to look at specific prefix or buckets and look at your operational metrics. We strongly recommend that you organize your data from day one because that helps us do our next step, which is to understand, analyze, and optimize your storage. As you use Amazon S3 to manage large, shared data sets across tens to hundreds of accounts and buckets in multiple regions, it becomes more and more important to be able to access complete and up-to-date information about your storage in order to make decisions or implement optimizations. To help, S3 continues to innovate by building features that let you manage data at the account, bucket, and object levels and make changes across tens to billions of objects with a few simple clicks. Our newest feature is S3 Storage Lens, which provides centralized organizational-wide visibility into your S3 usage and activity, as well as recommendations to help you optimize your storage. We also offer S3 Storage Class Analysis, which analyzes access patterns by different age groups to help you determine when to transition storage to less frequently accessed storage classes. And if you need to audit and report on the replication or encryption status of your objects for business, compliance, or regulatory needs, you can use S3 Inventory to get an up-to-date listing of the contents of what's in your bucket or across a shared prefix. But first, let's do a quick deep dive into Storage Lens, as was launched just a few weeks ago. First and foremost, it provides a large number of metrics, 31 in total, including both usage and activity metrics. Many of these metrics are brand new and have never been surfaced before, and the ones that have never been at these different aggregation levels. Which leads me to the next point, which is aggregation levels. S3 Storage Lens provide aggregation from the highest level AWS organizations down to the very granular level of prefix. Third, metrics are updated on a daily basis. Think of it as a daily snapshot to see how storage and what activity you had at the end of each day. Fourth is data retention. You have up to 15 months of historical data to analyze, enabling you to analyze and identify long-term trends and patterns, or even to time hop back to a particular date and to see a snapshot of usage and activity on that day. Fifth, the centerpiece of S3 Storage Lens is a highly visual and interactive dashboard, which is embedded in the S3 console, which can be used to slice and dice, drill down, and perform many other standard dashboard interactions on your metrics. Finally, the icing on the cake for S3 Storage Lens is a recommendation tool that helps you take actions and identify patterns. Once you've identified those patterns, take actions on those metrics by providing contextual recommendations. So let's do a quick tour of how S3 Storage Lens works. To start, we aim to make the configure of S3 Storage Lens extremely easy, but also provide a high degree of flexibility. For ease of use, all customers receive a default dashboard configuration at the account level. For those of you that are looking for a cross-account view, you have the option of creating a custom configuration using AWS organizations. And on the other hand, if you're looking to scope your dashboard more narrowly, you can select specific AWS regions and buckets. In total, you can create up to 50 individual dashboards, which allows you to do things like create a specific dashboard for each team within your account. Once configured, S3 Storage Lens will perform a nightly aggregation of your storage, usage, and activity metrics. For analyzing your daily metrics, S3 Storage Lens includes an interactive dashboard embedded in the S3 console. The metrics presented on the dashboard can help you better understand your storage with summary insights like, what's my fastest growing prefix or bucket? Or how much storage do I have across my AWS organization? Storage Lens also provides callouts for outlier data points based on 30-day trends, so you can flag anything or any unexpected fluctuations within your storage. Storage Lens also provides contextual recommendations to take action on those metrics that it's identified. For example, it can help you better cost optimize your storage or apply data protection best practices. Now that we've covered the pillars of knowing your application requirements, data organization, understand, analyze, and optimize, we can talk about continuous right-sizing for both cost and performance in the next few sections. First, let's talk about right-sizing storage. The best way to lower your total storage cost is choosing the right storage class for your workload. Amazon S3 has a number of storage classes to choose from. Whether you have demanding performance requirements, data residency needs, unknown access patterns, infrequently accessed data, or archival needs, S3 has the storage classes optimized for your data access, durability, and cost needs. So let's take a quick look at these different storage classes. If you know your data is active and frequently accessed and may be deleted within a month, S3 Standard is the best choice, designed for 99.99% availability, milliseconds latency, and designed to withstand the loss of a single AZ. If you know your data is less frequently accessed and not deleted within a month, use S3 Standard IA, saving up to 40% on storage costs compared to S3 Standard, but with a retrieval fee for accessing that data and a minimum storage duration of 30 days. You can also archive objects via lifecycle policies from any S3 storage class into one of the archive storage classes, S3 Glacier at 60% lower price than OneZone IA, or to S3 Glacier Deep Archive at the lowest cost storage in the cloud at about $1 per terabyte. If you can store your data in a single zone and it's infrequently accessed, you can also use OneZone IA with 20% savings over S3 Standard IA. And finally, for those that have local compute and data residency needs, you can use S3 on Outposts, which is a storage class designed for your AWS Outpost environment. Our fourth pillar is called continuous right-sizing, and the key part of that is continuous. Typically, we hear from customers that their data requirements change over time, and they need to optimize for each part of the data lifecycle. And there are two design patterns that we commonly see. First, customers use S3's building blocks of storage class analysis and S3 lifecycle to move data to S3's infrequently accessed storage classes and S3's archive storage classes. Or the second design pattern that we see is that they use S3 intelligent tiering for automatic cost optimization between the different storage access tiers. In the next few slides, we'll dive deep into both approaches. We touched on the value of using different S3 storage classes to optimize cost. Combining that value with S3 storage class analysis and lifecycle policies provides us a really good cost optimization pattern. In this approach, you start with storage class analysis to identify which data are less frequently accessed. Once you've identified those less frequently accessed data sets and their patterns, you can use S3 lifecycle to transition such data into colder storage classes such as S3 Standard and Frequent Access, and then perhaps even onto S3 Glacier Deep Archive. You can also use S3 lifecycle to expire objects in their older versions based on their age. Both transitioning to a colder storage class and expiring objects and versions you no longer need will lower your storage costs. This approach is great for predictable workloads where objects become colder or less accessed over time. Our second cost optimization strategy is using S3 intelligent tiering. Customers typically use this strategy if they have data with unknown or changing access patterns. You might also use an S3 intelligent tiering instead of other S3 storage classes if you're not sure or don't want to spend the time or resources figuring out your data access patterns of your storage. S3 intelligent tiering is the only cloud storage class that automatically delivers cost savings by moving objects between 4 access tiers based on changing access patterns. S3 intelligent tiering delivers millisecond latency and high throughput performance with a frequent access tier priced the same as S3 Standard and an infrequent access tier priced the same as S3 Standard infrequent access. And now, just announced, customers can also activate automatic data archiving to get the lowest cost storage in the cloud when data is not accessed for long periods of time. Customers can activate the new archive access tier, priced the same as S3 Glacier, or the S3 Glacier or S3 Intelligent Tiering Deep Archive Access tier, priced the same as S3 Glacier Deep Archive. In summary, S3 Intelligent Tiering can further optimize storage costs when access patterns change without any analysis, operational overhead, or retrieval fees. So how does S3 Intelligent Tiering work? For a small monthly object monitoring and automation fee, S3 Intelligent Tiering monitors access patterns and automatically moves objects that have not been accessed for 36 consecutive days from the frequent access tier down to the infrequent access tier. You can now, as I mentioned before, you can now also activate one or both of the new archive access tiers at the bucket or for a specific prefix or object tag set. If you activate both archive access tiers, S3 Intelligent Tiering will automatically move objects from the infrequent access tier to the archive access tier after 60 consecutive days of no access. Then, the objects will move from the archive access tier to the deep archive access tier after an additional 90 consecutive days of no access. You also have the flexibility to extend this time to automatic archiving by up to 2 years if you need to retain that millisecond latency. Anytime an object in the archive access tier or deep archive access tier is restored, the object will automatically move back to the frequent access tier, as little as a few hours. As mentioned earlier, there are no retrieval fees associated with S3 Intelligent Tiering, and is ideal if you have changing or unknown access patterns. We've been talking a lot about optimizing storage costs, but for active workloads with lots of requests, it's also important to think about request costs. And as you can see, there's a relationship between request costs and the object sizes for a given amount of storage. So we recommend that customers batch small objects into larger objects to reduce the total number of requests, and therefore reduce their total request costs. This is particularly helpful if you have small files. For example, let's say you have IoT sensors that are sending kilobyte-sized messages to S3. Before uploading to S3, we'd recommend that you would batch these into larger files. In addition to reducing request costs, this also helps you take advantage of all of S3's storage classes. For example, S3 Standard Infrequent Access has a minimum object size of 128 kilobytes. In general, we'd recommend batching small objects into larger objects on ingest. If you're using AWS tools like Amazon Kinesis Firehose, you can set the thresholds within the service to batch objects before uploading to S3. If you have existing small objects in S3, you can use services like Amazon EMR to combine small objects into larger objects. We're going to switch gears a bit here and talk a little bit more about performance optimization. One of the key things that I always start with is a view into how AWS builds its infrastructures and regions to deliver the availability, durability, resiliency, and performance that you require. Each AWS region is made up of a group of availability zones, or sometimes referred to as AZs. Each of these AZs is a standalone data center or a cluster of data centers on a single site. And they're typically a few miles apart to isolate them from local failures like fire, flood, or power failures, but they're never more than 100 miles apart, so we can retain super high performance for S3, even when we're protecting that data by writing across each AZ in an AWS region. As a result of how we build our infrastructure and that Amazon S3 is a regional service, it's important to first look at the mental model with how to interact with S3, because this is different than how you should interact with some other storage services or on-premises file servers. With S3, you should think about the service as a very large distributed system accessible across a wide pool of endpoints. Within a region, you should spread these accesses widely across these endpoints, and that applies whether you're accessing a single large object from a single EC2 instance, or if you're scanning petabytes of data in your Amazon S3 data lake from a large EMR cluster. Using parallelism across the S3 endpoints allows you to benefit from the scale of S3. In doing so, you can fetch data and achieve multiple gigabits or even terabits per second. So if there's one takeaway I want to impart during the performance section of this presentation, is to take advantage of S3 scale by horizontally scaling your workload. In the next few slides, we'll talk more about how you can do this. First, let's talk about the relationship between request size and latency. Intuitively, if you make a larger request, you'd expect that request to take longer. So the way to improve total latency is to make a number of smaller requests in parallel. For example, if you're uploading a large object to S3, you should use S3's multi-part upload and upload these parts in parallel across multiple connections. Alternatively, if you're downloading a large object, you should similarly make a number of small byte range fetches in parallel over multiple connections. The higher level SDKs like S3's Transfer Manager will do this for you automatically. But previously, when we talked about cost, we said that you should create larger objects to reduce request costs. And now, when we're talking about latency, we said that you should reduce request size to reduce request latency. So what is the right request size then? It's really up to you and your application requirements. However, most customers find that the right default request size is somewhere between 8 to 16 megabytes. That's the same kind of default the AWS CLI uses when making a multi-part upload. We've been talking about performance in the context of a single object upload and download latency. However, many applications perform activities like MapReduce and access thousands or even millions of objects in a short period of time. The same principles apply here though, where you want to take advantage of S3 scale by spreading the request load across your object key namespace. Your application can achieve at least 3,500 puts or 5,500 gets per second across a prefix. There's no limit to how many prefixes that you can create within a bucket. For example, if you wanted to create 10 prefixes in a bucket to parallelize reads, you could achieve 55,000 read requests per second. The key here is to spread your request load across many prefixes in a bucket. Okay, now that we've covered the fundamentals of optimizing for cost and performance, let's put these into best practice with a case study. I recently worked with a social media platform that is processing over 1 billion of events daily, storing petabytes of data. They ingested events through Amazon Kinesis Data Firehose to their Amazon S3 data lake. Once in Amazon S3, they ran hourly EMR jobs to batch, transform, and stored the data in Parquet format. Then they consumed the data with tools like Amazon Athena. From the S3 point of view, they first loaded the raw data from their Kinesis stream, transformed it, and then made it available for their business analysts to query in their production data lake. They keep this data around for long periods of time as historical data. Next, we'll look at how this customer optimized for both cost and performance for each stage of this data workflow pipeline. Since this customer was using Amazon Kinesis Data Firehose, they are able to batch the events into larger objects. This helped them reduce their total number of requests and their request costs. They also used a GUID in their key name structure. This helped them create many prefixes to spread that load across their key name space. Finally, they set the default storage class as S3 Intelligent Tiering. For their business, they've chosen to keep their raw data around for long periods of time, and S3 Intelligent Tiering helped them automatically cost optimize their raw data. Other customers we've worked with have chosen to delete their raw data after it's been transformed, making this data often short-lived. For these customers, they'll choose S3 Standard for their short-lived data. Next is the production data lake. This is after the data has been transformed into optimized files like those in Parquet or ORC format. These files are typically anywhere from a few megabytes to a few hundred megabytes. To improve the throughput of these large files, we'd recommend using multi-part upload and byte range fetches to parallelize across multiple connections, improving the performance and reducing overall latency. We also find that a lot of customers use S3 Intelligent Tiering for the production data lake storage. It often has unpredictable access patterns with many business analysts accessing their data to get insights out of it. Finally, as data ages, it often turns into historical data that is rarely accessed. For this customer, it was important to keep this data around to run machine learning model training at a later point. However, this data can be offline in an archive. For historical data sets like this, we'd recommend using one of the S3 Glacier storage classes or opting in to the new S3 Intelligent Tiering archive tiers for automatic archiving after the data is no longer being accessed. The choice of which S3 Glacier storage class to use or which archive access tier to use really depends on what your restore requirements are. The main difference between Glacier and S3 Glacier Deep Archive and the two archive access tiers in intelligent tiering is the restore experience. With the S3 Glacier storage class or the archive access tier, you can get your data back in as little as a few minutes using an expedited retrieval, or in a few hours if you prefer a bulk retrieval. On the other hand, if you can wait 12 to 48 hours for your data, you can use S3 Glacier Deep Archive or the S3 Intelligent Tiering Deep Archive Access tier to store your data at the lowest price in the cloud at about $1 per terabyte. We've now walked through each stage of this data lake workflow. And the key takeaway from this case study is to achieve the highest performance and achieve the most cost-effective storage. It's really important to optimize for each stage of your workload. Let's put it all together with what we discussed today. First, it all starts with understanding your application requirements, and you are the best person to know what these are. Second, you should organize your data using buckets, prefixes, and S3 object tags, as they map to S3 features like storage class analysis and S3 lifecycle, and we highly recommend you organize your data from day one. Third, monitor your data using tools like S3 Storage Lens to help you understand your data, which can help you optimize for both performance and cost. Fourth, scale your choose the right storage class for the most cost-effective storage for your workload. Fifth, to achieve the highest performance, scale your workload horizontally to maximize performance on S3. Finally, it's important to optimize cost and performance for all stages of your workload. This concludes our session on optimizing Amazon S3. Thanks for your time today, and happy building on Amazon S3.